Hello, everybody. Today I am going to take you to the edge. That reminds me when we were postgraduate students, we looked at the classified section of a newspaper on a afternoon. No beers were consumed before that, and we bought a paraglider and we climbed, dunes much higher than those and jumped down and literally what could possibly go wrong. I was wearing a lead jacket because the parachute was actually a little bit too big. We didn't really realize they were, tailored for different weight classes. And my friend Paul used to say, well, what could possibly go wrong if you're not living on the edge? You're taking up too much space. Now, jokes aside, this is actually something our group has been working on for the last 5, 6 years or so. And as you actually march through university from the first year, second year, and into third year, we are going to have an increasing emphasis on original research rather than just regurgitating textbook stuff for you. So I'm slowly trying to basically wean you off, the standard textbook marine biology 101 knowledge here and actually expose you to some of the work we do. And hopefully engender some sense of excitement, some sense of awe in you. Now, when students say, "Well, what do you academics actually do?" There's various ways we can actually tell you about how amazing we are. But basically, what I did here, I put the diagram together where the size of the letters or the words signifies how often, relatively speaking, a particular term appears in the title of the papers, the publications we write, and you can see it's kind of a mix of everything. Really done a fair bit of work in estuaries, on submarine canyons, of course, ocean. I'm an oceanographer. All of our work is, mostly conservation orientated, and it's, geared towards management, restoration, and of course, we have done a fair amount of work on ocean shores and sandy beaches. Another way of basically displaying that is, yes, I bob around on the ocean a little bit and work on particular submarine volcanoes, seamounts. We also work on submarine canyons down in the south. Fair amount of estuaries, fish, plankton, oysters, and so forth. But today we're going to talk about sandy beaches and the scavengers on sandy beaches. Now, diving into that a little bit closer. So, what do we really do in the coastal zone? In my lab, we work on reef restorations. Ben Gilby is going to tell you more about that. We have an active program working on turtle nesting. We work on habitat selection of birds. We work on surffish. We work on vehicle impacts. Well, not those sort of impacts, but the ecological impacts. We also develop health indicators for beaches. This is a ghost scope here. We work on the impacts of coastal cities. But today, otherwise, it's going to take 27,000 hours to talk about all of that. I'm going to focus on birds of prey, scavengers, invasive species, and what we call maritime carnivores. Now, why do we work on those kind of systems? Well, firstly, they are fascinating. And this is actually what a good photograph, one of our students, on the first island trip, and it's all very, very, picturesque. And this is me much less so picturesque. And The good thing about being a dad is when you go on holidays with your kids, this is more or less my standard position. I can embarrass them all greatly because being a good biologist, I spend a great deal with my nose fairly close to the ground, studying dead animals on beaches. Now, most of our shores, or most sandy beaches worldwide, are littered with the corpses of dead animals. Here we got the seal. This particular one actually exploded after a few days. That's down near Eden in New South Wales. So that was a bit of a tasty and smelly affair. Here we got Flipper on Morton Island, not laughing anymore. Here we got penguin. We got an albatross on Fraser Island. We've got porcupine fish, and COVID restrictions don't allow us to travel right there, right now. But the moment the borders open again and we get permission to travel from the university, this is where we're going to go, up near Alaska, and I got some contacts up there, studying dead animals again and the carnivores eating it. Now, it's of course much more attractive to study the consumers of dead animal flesh, such as those birds of prey. And we got a fantastic, basically, opportunity on our coast here. It's not actually that hard to actually get those shots. You just need a bit of patience, very simple gear, and off you go. This is actually done with a GoPro, just one of the basically screen grabs on North Stradbroke Island. And here is a dingo. Now, I just put that one in. If you ever actually, hang on, let's go back here. If you ever thought that dingoes are just harmless dogs, we observed this one here a few years ago cracking open a coconut. Now, if you ever have tried with a spade or a hammer to smash a coconut, you will actually know that they are very, very hard. So I have to say that instilled a newfound measure of respect in me for dingoes, which everybody should really have. And we do a fair bit of work on those kind of guys. Look at this, cute little fox trying to steal the fish off the beach. Sometimes we get extremely lucky. This is a very rare record of an eastern quoll on a beach in Tasmania. I happened to actually run into the guy who worked on them for 20 years in the pub. He just had retired. It was his retirement, basically farewell, and I showed him these pictures which I had on my phone. He's like, "Oh my God, where did you get that from?" I said, "Well, on the beach." I said, like, "Oh, I don't occur on the beach." I said, "Well, maybe you haven't actually looked at them," and they actually admitted to it. So we actually get a fair number of what people have considered to be terrestrial predators to come down and scavenge on the beach. And look at this one. This is a mullet. And boom, 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 who comes up here? Straight up from the shore. He must have actually run across and smelled it. A Tasmanian devil. And we got actually many records of those at various beaches around Tasmania. We're not quite done with Tasmania yet. There's still some helicopter work to be done on the west coast there. Here he is trying to get this very, very big mullet, trying to get away with it, showing us his bum. Off he goes. And here is a fox that's actually on the Noosa North Shore. And there's another fox coming and said, "Whoop, this is my fish. Bugger you, I am opposite." And we will hear quite a bit about foxes in the next half an hour or so. Now you might say, why do I have such a fetish for corpses on the beach? And I should say, all those pictures actually are taken either by myself or some of my students. And so if you like wildlife photography, they're actually, very good places to work at and very good study subjects. Well, the first reason is we like as ecologists to think that the ultimate study subject I want to have, the most glamorous one of them, is to actually study big predators, bears, lions, tigers, hyenas, whatever. But the reality is almost all vertebrate predators are predominantly actually scavengers. There's also quite a bit of theory that possibly or probably I should say, the early ancestors of humans were actually scavengers along maritime shores and lake shores. And we also know nowadays that not actually the majority of animals are actually prey animals, are killed by predators, but actually many more die from disease, exhaustion, parasites, and so forth. So that actually makes animal carcasses surprisingly abundant. And when you actually go and consume animal flesh, it is the most nutritious of all the food items you can actually consume. And very rarely do we go down the street nowadays and basically uh, wrangle a cow to the ground, or a sheep, or a goat, or a rabbit, or whatever. No, actually, we go to the supermarket or the butcher and we scavenge for bodies there because it is much more energy efficient to eat animal tissue, which is already dead, rather than trying to subdue it, to chase after it. Very, very energy uh, costs a lot of energy, costs a lot of energy. Uh, and also, predators are usually quite wary hunting if they don't have to, because there's always the risk of injury. So, over the last decades or so, there has been a fundamental shift in our understanding of predator-prey relationships to basically to become something along the line of carrion scavenger predator prey relationship. So, scavenging, the consumption of corpses, carcasses, whatever you want to call it, is more abundant, more prevalent, and more important than we have traditionally thought. Now, if you're a good ecologist, you have to basically measure the correct things. And the representative thing to measure in food webs on beaches turns out to be carcasses and the animals consuming them. Now, the habitat we work at is an edge, is the land ocean edge. Now, another thing which you basically should cultivate there is that you should be a biologist at all times. So, that was 2 years ago. We traveled through Chile and we just took the very last plane out before the COVID lockdown. We didn't even know, we just came down from the Andes. Luckily, we actually had a secure ticket and off we went. And the next day it was all over. And as I was actually driving along here, I said, like, whoop, stop, look at this beautiful edge. Here we got a vineyard, and here we got no vineyard. Now, here is another edge. That's the view down from the Noosa National Park towards Sunshine Beach, Sunrise Beach, and so forth. And here we got another edge, and we have a desert here, and a very, very rich upwelling region, and about 200 meters or so. Look at this beautiful hummock dunes. One of my favorite beaches. It's in the north of Chile, of an interface or transition zone. So edges are everywhere in the biosphere when you look at it. And there's quite a lot of theory surrounding edges or interfaces, whatever you want to actually call them. But most what actually is of relevance here is that many of those fundamental theories posit that edges are hotspot regions, that ecological structures and functions are elevated. They peak at that very narrow transition zone of edges, mostly because resources get concentrated by physical processes, and also, and this is much more important, is species from both adjoining habitat types often concentrate or mix, so you get actually the best of both worlds. That used to be a USC slogan. At edges. So here we got an edge, a river going through an agricultural landscape. Those are rice or vegetable paddies. And here we got actually road edges. Road edges are very, very interesting habitats. And I knew that because my dad was a botanist and he had to stop a lot to look at planty things at the side of the road. However, we look at a much better edge, and here's my favorite person, it's my daughter, a long-suffering field assistant, looking down at this edge. She probably thought like, oh my God, do we have to sample that? Can't I be on holiday at least once? The answer is no. Sometimes, in tropical settings, that's up near the Daintree, crocodiles out here, or beautiful looking down from the headland on to the main beach of North Stradbroke Island. You got all these shark attractants here. I think they're called surfers. Here's another one. I don't know if I have two. And we work on beaches because not only are there cool places to work at, but they're also essentially the one habitat, the one environment where most of the human population interacts with the ocean. Probably 99.99% of people have an experience of the sea on a sandy beach and in the surf zone. That is basically an indisputable fact. So beaches as systems have an enormous social, cultural, historical, artistic, whatever way you want to actually express it, value. They also are prime real estate. This is a photograph of the Gold Coast, also known as a sunny place for shady people, but let's not go into that one. And of course, the importance of beaches is often very, very, starkly and magnificently illustrated, I should say, in the Australian context, where we have this almost, all pervasive, iconic beach culture. Sometimes it actually goes all bananas, like here on Australia Day down in Mooloolaba. Of course, surf lifesavers. How many advertisements overseas have I seen of Australia which actually feature the beach? And invariably, then they will actually have, surf lifesavers. And my dad is 85 and he watches Bondi Rescue in Austria in the middle of winter. Here we go. That's not Bondi, that's Mooloolaba, but never mind. And yep, what can one possibly say about this one? The boys built themselves a bar here on the dunes to drink, and again, all value judgments being put aside here. It is an expression of a value. Whether you agree with it or not is irrelevant. It just actually means the beach is really one of the places we as Australians and many other cultures around the world identify very strongly with. I took this photograph of this chap, at 5 o'clock in the morning up at Tiva Beach, and I think it's just fantastic. It's the soul of the earth, goes there, wets a line, and it's just, I think a beautiful image of not only the tranquility but the deep value we actually, attach to beach systems. And of course, beaches can also feature as a nice backdrop for Land Rovers. Don't get me started on Land Rovers. And this balloon, I just drove past and I took a photo with the Land Rover in the back, and that's actually featured in a campaign about beach litter by the Queensland government. There you go. So beaches are prime edges. And that actually means they're not only prime edges in terms of human use, but they are the single longest interface region between the ocean and the land. More of exposed coasts along the world is made of sandy beaches than by any other ecosystem. So forget about, it always goes first. Forget about seagrass, mangroves, rocky shores, those kind of things. It's really beaches which dominate the world. We cannot separate beaches, from the dunes here, and the surf on this side. We actually regard them as a single functional unit. What is actually interesting is there's a long established, well, not actually all that long, about 30 years ago, paradigm which says, well, beach consumers, the animals on the beach, rely overwhelmingly on marine inputs for food. Not much actually grows there. There's no botany, yay. There's a bit of phytoplankton grows in here, but mostly it's food from the sea which washes up on beaches. Beaches are depositional environments, and ultimately, I would say, if a dead body in the sea doesn't sink to the deep sea, where it actually is consumed by deep sea scavengers, it will actually at some point, or is consumed on its way to the beach by sharks and other things, it will actually land up on a beach somewhere along the world. But here's the thing. About 10 years ago, after having worked for 10 years on beaches in the region here, we were on a beach on the main beach of Stredi, and I sort of thought, whoa, do I really want to take another sample and look at empty boats and boats and snails crawling in the sand? And I looked up, and there was a white-bellied sea eagle, and I thought, like, I counted a fair few of those, but what do they actually do? What is the biological dynamics and the spatial footprint, so the spatial attributes of food subsidies which come onto the beach, i.e., what is actually happening there in terms of the energy exchanges? And I always say to any student, saying, asking, should I really actually become a marine biologist? Because surely everything has been figured out. This is a clear example that once we actually started to look, it actually appeared that no, not much work has been done at all. As a matter of fact, we started it. Hello, here we go. It's a complete empty space, waiting for us, like an empty canvas, like a blank canvas for us to actually paint on. So I stumbled across that road sign in one of my favorite cities, Bordeaux, in France 2 years ago, and I had to laugh because it is the Rue du Moulet, for mullet, of course, because we use a lot of mullet in our research, and those are ocean mullet which we buy in bulk by the thousands, literally, from three bait supply. So it's all done, above board. Then we measure them all and we tag them all, and you see those numbers here, 2,600 or whatever. And there's grades and grades of mullet. And you might say, why do you use so many mullets? Well, it actually turns out to be mullet, sea mullet, Nudocephalus is probably the most widespread and abundant fish in the surf zone of sandy beaches. So it's a naturally occurring, animal, which we can actually then use in a sensible fashion, in experiments. So we're not actually introducing something very, very artificial, to the system when we work there. The thing about mullets is that they look kind of fine here, but But as they sort of defrost, they give up off this. Ooh, yeah, I don't know what this one is. They give off this what we actually very endearingly call the mullet juice. The mullet juice is a very, very powerful uh, substance. Uh, and there is just no way getting away from the fact that after a week in the field, just everything smells of
Come
mullet
on.
juice. This is my long-suffering daughter trying to actually get up the sand dune with a bag of mullets, and you can
Hey,
actually
Izzy,
see.
what's in the bag?
Ooh,
Let me
what's
see.
in the bag?
Let's see what's in the bag. Ooh, what's the? Let's see what's in it. Ooh.
Yep, and so we all go slowly mad after a week climbing up and down dunes, and you will actually see what we actually did there, and basically being dribbled on in various forms of mullet juice. Now, then we just actually use some, standard wildlife cameras. You can buy them from Aldi now. I mean, people have very distinct opinions what actually works best. I don't think there is actually a better or worse camera. You will actually do all of that, during your studies here. You set them up, then you take pictures of strange characters. This is actually, oh, I just realized this is actually, a new shirt. It's not the same because you can never actually wear that shirt again after working for a week on mullet shoes. Sometimes you lose a Land Rover. This one was actually not looking that good because it actually got filled up with sand uh, right up to the door sills. And basically, that technique here is a simple one. And then you have to think very carefully about the ecological questions you're going to address using it. Now, this is, some of the stuff we actually have done. We actually worked on food web controls. We worked on, urban ecology and ecological health using the scavenger examples. But today I'm just going to give you some examples about what you can do in terms of invasive species ecology. We're going to talk about basically foxes on Australian beaches. We're also going to talk a little bit about, uh, carrion quality, but I think the most fascinating aspects are is getting a handle on the true nature of those spatial gradients across those interfaces, and also working on a grand scale, the biogeography of rotten animal flesh on the beach. And actually, the biogeography theme is one which we're going to develop much, much more. However, there is this small little problem called COVID. So we have to basically pause all of that. But, Alaska, Namibia, and Argentina, here we come. Right, let's get straight into it. Now, here's a fox. Foxes are probably, well, if you read various publications, quite often red foxes are considered the most widespread and abundant medium sized carnivore in the world. So here is a fox, eating oyster catch eggs on a nest on Australia, which we basically captured with the camera. And that gives an indication that they're considered an enormous uh, problem animal in the Australian context. Why is that? Well, you will actually not believe that when the settlers, down in Mexico, no, sorry, Victoria, near Melbourne, actually near Geelong, established the first, farms on the grasslands there. They said, well, there's nothing to hunt. So what did they do? They basically went sent back for a few foxes from the mother country, tally ho. And the rest, as they say, is history. So the foxes just, blossomed and spread out from there. Now, the literature on fox ecology in Australia is almost uh, completely dominated by the detrimental impacts of foxes on wildlife, and there is no denying it. But what we as true and good ecologists have to do is not so much actually buy into the invasive species bashing and all the nasty language which comes with it, but actually ask what is actually the functional role of foxes. They're going to stay here. They're not going to go away. As a matter of fact, we have just done some work which shows that the one factor which has no bearing whatsoever, there's the one thing which we could not make work in any of the models to influence fox numbers on the coast here is the level of fox control by council, which is actually quite funny. I can tell you, all about that, but maybe actually off camera. So, what is a irrefutable fact is that foxes are part of the landscape and they're part of our food webs. So we have to actually ask, what do they actually do in coastal food webs at the beach dune surf interface? Well, and we have done quite a bit of work on that one, as you can see here. And it turns out to be, we started out with a fairly simple experiment because we thought like, woohoo, luckily foxes have not made it over to Moreton Island, or at least there's no record of it. There's also no wallabies or larger macropods on Moreton, and that is a complete mystery to anybody. I have asked so many people and nobody knows, but here we go. But there's feral pigs there. We've actually seen them even eating mullets on the beach, believe it or not. But on Stradey, there is, quite a bit of, fox control, but it is never 100% successful. So when we did the study here, there were quite a lot of foxes, on the beach, facing eastwards. So as an ecologist, this is a dream scenario. So what we did, of course, is the two communities, the scavenger communities between Stradey and Moreton looked very, very different. Here we got a white-bellied seagull, we got a whistling kite here, got a Brahminy kite, got a Norwegian crow, silver gull, fox, but foxes were basically found on Stradey only. And look at this, a feral pig, a water rat, and a bush stone curlew. All of those were seen to actually interact with corpses or carcasses, mullet carcasses on the beach, although, of course, the raptors here and the foxes were the main consumers. And to cut straight to the chase, this is basically a technique I borrowed from medical science. In medical science, when we do a trial, or when a trial is done, basically there is a number of patients and they're being given different treatments, and then you actually work out survival curves. And we could do exactly the same, and we say basically each mullet, each carcass on the beach is a patient, and we have two different treatments. We have North Stradbroke Island, and we got Stradey. We got fox and no fox. So essentially, the red line here represents the fox treatment, and the blue one, the no fox treatment, just like a medical trial. And then you can actually work out, what the survival curve is of each of those patients. Now, as it turns out to be the case, during the day, the curves are very, very similar. Another cool thing is that, you can use all sort of fancy, medical, or statistics developed by the medical research community for that. And oddly enough, when I actually look into some of the, COVID, vaccination trials, I actually often quite think back on actually doing this, particular work. Now, during the day, not much of a difference, but what happens at night? Basically, most of the patients, i.e. the mullets on the no fox treatment, survive. There's very little predation at night because it's all done by birds of prey. But once the foxes actually are present, more or less 80% of carcasses go. So what we actually find here is there's a huge consumptive effect, a resource depletion effect, uh, operating on our exposed shoreline. So we actually call this the Fox effect. Now this was actually just basically Fox and no Fox. So we said like, well, does this actually operate, in a more nuanced setting, and does it actually depend on how much biomass of dead animal tissue, i.e., how many corpses are available? So that led us to a really cool question, I thought, and we actually drew, various, conceptual diagrams, but it basically came down to a very, very simple scenario. Although nobody actually has asked that specifically for foxes in Australia, which is, I think, quite amazing if you think about how many fox researchers are out there. So essentially, when you add an invasive species into a system, okay, three different things can basically happen. Either bugger changes, we call this functional equivalency, or the new species does something which the native species pool basically either does but not as well. You just basically add functionality to it. You increase the rate, it's a functional gain. Or by interference with the native species, there is a loss. And this is actually, most people would have actually predicted the rates would actually fall. So in other words, when we have a certain size of the carrion pool, here we have a situation where we just have basically birds of prey. What actually happens when we add foxes to the mix? Do things basically stay more or less the same? Do the foxes actually augment the ecological function, or do the foxes depress it? And remember, all our ecological thinking here would actually go based on the invasive species literature, into this kind of direction. Now, devising an experiment which actually can test it was rather difficult. So what we did, we basically went to the Nusa Nordsjö up to Diva here, and again to Stretty, and there was a little bit of a variation in basically fox numbers and in fox presence at different stations. And we actually had 4 different treatments. We added either only one large mullet per site, or about 8 kilograms, basically a box, a larger box, or 2 boxes, or basically 50 fish. And this is why some students actually call it the big mullet. So essentially, we predicted that once there would be an almost overwhelming resource pool, foxes would not make a difference anymore, but they would make a difference maybe at the lower resource availability. And here you can actually see, Hayden still looks actually reasonably motivated. So not so much. Each of those sites had, of the big treatments, had 50 fish. They were at 10 sites. They were inland. They were on the beach, and we actually followed each fish. That's why we tagged them for a week. So there was an enormous amount of work expended on that work. And this is the very, very last deployment, which we finished. You can actually see all the fish nicely lined up here. In case you wonder why some of us are very gated, because they're a bit sissies, is where are these slithery things down here in the dunes. And we smelled absolutely delightful. And you see some actually really cool stuff here. I mean, the lizards, they had literally a field day. So this guy's like, I really need to get this really early big fish up into the dunes. Here's a white-bellied seagull sitting here. There's another one coming in, and he's making a swoop, and whoop, off he goes, a juvenile one. And of course, foxes at about half the stations. And what you can actually observe is that the foxes have a behavior called food caging. They would actually come back to a station repeatedly throughout the night, and they'll probably take them away and bury bury them somewhere to have a nice, mullet cage somewhere in the dunes. You see this guy here, and here comes a competitor like, whoops, I'm going to have more of those fish. He's not so happy, like, look at the behavior, fantastic. Now, to cut to the chase, we found a lot of variation in the relative contribution of foxes to the scavenger pool. Those are the red segments here. They changed over time, but by and large, it did not matter how much the foxes basically ate. There was no change in the overall curve from what we actually could detect between the two treatment scenarios. So this was kind of cool because there is a fox effect in terms of the timing of carcass consumption, but not so much actually when it comes to the overall rate of carbon processing. So essentially, coming back to our original hypothesis, about 2,000 mullets and about 320 Cameron nights and days later, we actually have proven that there is actually fox equivalence, which is kind of cool, but it actually raises questions. It raises questions about essentially what would happen if basically we could actually work on those, and there's just no way we actually get, and I have tried and tried and tried to get permission to work on dingoes on Fraser Island. It's a pity. So essentially what we have found is that the invasive carnivores are a functional part of coastal food webs. We have found that the invasive species, the foxes, can do the job of native species, I should say, the birds, rather well. And we do actually have limited evidence for functional replacement of raptors by invasive red foxes because it actually stays pretty much the same. But is there now a question to be asked that could we actually really stick our neck out here and say, are scavenger assemblages more resilient to invasive species, bold claim, or is there a greater inbuilt, so to speak, redundancy and complementarity which we can find in scavenger food webs as opposed to predator-prey food webs? And this is actually something, which nobody actually has tackled so far, but we will. Right. Now, a few years ago, a few other, shady characters, which you will actually see repeatedly at USC. We wrote this kind of paper where we say, look, how do beaches actually, function, and what are the key traits? And what it actually, occurred to me is for years and years, Sandy Beach ecologists have actually drawn up those kind of diagrams, and it's essentially we got the surf zone, we got a fairly narrow beach, and then we cut off the dunes here, and we say, whoa, it all happens, in a fairly narrow, compressed, basically edge. So we talk a lot about edges, the ecodomes, the interfaces. We talk about, things are enhanced, they're elevated there, there are hotspots of function, resources and predators are concentrated, blah, 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 blah. So the picture we paint, or we used to paint, is one where things happen in a very, very well, clearly defined, narrow spatial corridor. And then it occurred to me, nobody has actually measured that. So sometimes you have to do the really, really simple thing and actually determine what is the spatial attribute of a particular process that you study. So isn't it a nice photo? I want to look at one. Nice, ready. So we have a beach here, but how much further does that edge actually extend into the dunes? So again, we worked up on the the North Shore and on Stretty, just to actually have some replication in the system. We did, a lot of mullet placements and camera placements, basically right at the edge of the dune, at the base of the dune where the bare sand starts. And then each of those dune sites or beach sites had an upland site in the dunes, which is basically we took a random number generator and we said go from 0 to 350 meters inland. Boom. And we gave Hendo, we gave him a GPS and said off we march. And we actually all trundled after that, which is really, really quite fun, with Sulam Tarnapush and all other sort of stuff. And essentially, it all became a bit unstuck when you actually go up to Tiva, because you actually have to climb.
For the camera, Christine.
And this is actually Christine, who came over and worked with us from the States, and she couldn't believe, the steep dunes. And if you actually climb those dunes every day for a week at 10 sites with mullets and cameras, get reasonably fit, but had to be done. And to cut to the chase, if you want to actually see things happening, at least when it comes to scavengers and animals on cameras, don't waste your time in the forest. Essentially, what we found, that the pattern went like boom, straight down. Everything happened in the first more or less 50 meters, and then we didn't really see terribly much action at all. So really, it turns out, yes, it was all concentrated at the beach dune interface. And again, it did not matter what the species composition was. There's a lot of functional redundancy, apparently, in the community, which basically means the different species can all do more or less the same thing, and they can stand in and basically play different. They can all take on the part which needs to be played when it comes to carbon processing. But it doesn't really matter whether it's a Brahminic kite or a monitor lizard. Kind of cool. Now, again, here is action on the beach, and here is a guy on a sand blow, and this is our latest work from January this year. And the question then is whether the beach actually extends inland, where the dunes have actually bare sand patches. What we really found was fascinating is that the only sizable consumption when there were no foxes was by the Lay's monitor lizard. You can actually see this big fellow here under a pandanus tree. The mullet is down here. And you can see him here, and there's actually very, very thick undergrowth. And basically, I think 8 out of 10 sites. There we go. Isn't it fantastic? Off he goes. 8 out of 10 sites had those big lizards, those big reptile consumers, which again, nobody else in the world for beaches has reported before. Now, this mullet, as you can see, is missing an eye, but we can also see there's all these holes on the side here. Usually after a few days, animal bodies rotting in the Queensland summer are not very charming, to put it mildly. We have actually almost a complete takeover of maggots, of fly larvae.
Turn it over.
Look at this, this is about 3 or 4 days old, in about February up on the shore.
That was already flipped.
Maggots wiggling away.
Hang on, now I do want to. School, what are we going to have for dinner?
Should we go again?
School, what are we going to have for dinner? Turn it over, please.
Uh-huh.
and the smell is really quite
Oh
something.
my god. Oh.
These are much less. They're like a day or two behind, aren't they? In deteriorating.
Oh god.
So you can actually see, that not only do they look disgusting, but it also smells disgusting. Now, the word disgusting doesn't really, enter horribly, so that's what we thought as scavengers vocabulary. What is actually much more interesting is to actually think, see, this guy is actually, getting down one of those really badly rotten nuggets. So we thought the only consumption which we really saw in the forest of, putrefied fish was actually by reptiles. The other ones, not the foxes, and the birds would actually not touch them anymore. That raises the question then, do we have some sort of toxicity developing uh, to the point where scavengers or most of the scavengers would actually be repelled from actually eating a putrefied carcass beyond a certain age? So what we did, I have an ex-student of mine. His father is and him they're professional fishermen down at Bribey. So we went down and they went up with us and basically caught the fish for us because we were like, if you ever thought, you can actually fish. I mean, those guys are the absolute pros, and we actually needed about 100 whiting of the same size. And Greg just said, "Yeah, here," and the net goes out, and we had them literally in about half an hour. So they all went into sterilized eskies. Here we actually see some good sized whiting here. And what we actually then did, we had a student, McKeely. You can actually see the dunes whale here, up, just down from her house up at Berigian. We put them in metal cages, and as you can see, every day McKeely went and she harvested a few of those fish, but basically we let them rot in the dunes. And what actually happens is after a few days, basically, they started to actually get maggots. But as they actually, rotted even further, they started to actually dry out, almost like dried fish. And what actually turns out to be the case is we tested the toxicity of it by actually using a cell assay. McKeely basically, chucked the fish into a NutriBullet. It all spun and, became very, very, an interesting cocktail. And then, we incubated, cells, with the juice of mullets of different ages and actually counted which ones, how many cells survived. And it actually turns out to be the case that both fresh carcasses and old ones have very, very low toxicity, whereas like middle-aged ones, basically seem to be, probably are best avoided. What that actually means is that there is obviously some sort of evolutionary price to be paid for eating a carcass, which the reptiles seem to have mastered, but probably birds and mammals do not. At this end of the scale here, it's probably quite rare because most carcasses in nature, unless they are in the forest, get actually consumed before that. Now, and here for something at a much bigger scale, there's this cool website called The True Size Of, and you type in whatever you decide you want to check. And this is actually Australia superimposed on our neighbors here. Up. I sent this one on Singapore. You can see big island, but that's cool. So think about this fellow here, Alfred Russel Wallace. He was more or less the founder of biogeography, working in this region here, and a major shift in faunal communities, which actually runs more or less across here, is called the Wallace line. Now, biogeography is a funny science because it actually goes nowadays beyond merely describing what occurs there. We can also possibly make some functional predictions. Now, here we got two, it's a bit of a ridiculous example. We got a community of birds here, budgies, up near Darwin, and an old drawing of penguins. Now, both of them are birds. And you can actually ask, well, if they're all birds, do they all do the same thing? In other words, this is a hypothesis I really love because I can understand it. You can actually say it doesn't really matter what the species composition is, the exact nature of the species making up an assemblage, the rate stays the same if you actually go from one extreme to the next. So here we basically have any sort of rate, an ecosystem function that can be scavenging, that can be respiration, that can be predation, that can be nutrient regeneration, whatever you want. And you measure that across a biogeographic range, and your null hypothesis is there is no change, i.e., there is redundancy built into the system that different species can take on the same role, irrespective of where you go, or as you basically march along, let's say, a climatic gradient. So basically, remember, we predict there is no change. You might say this is a bit ridiculous because surely we know the Earth is all structured, in a spatial mosaic where things are very different from, as you go from A to B, from the rainforest to the Arctic tundra, from freshwater streams to the deep sea. Well, let's see. So, Australia being a fairly large island, we could actually think of, a reasonable large-scale test, and we went up, it actually looks like far north Queensland, but it was still a very, very much longer way to go. But that's basically from Cairns upwards, and then we went down here to Victoria, and we did exactly the same experiment, obviously in different places, comparing tropical versus temperate biomes. In each of the biomes, we had 12 beaches. On each beach, we had 4 sites. At each site, we had 2 fish. And we actually had 4 different deployments per site. So a lot of application. It was a large-scale study, and but it was actually quite good fun actually doing it. And at the face of it, most people would have said, "Ooh, I actually reckon we get higher rates up here at the tropics." When you talk to the Mexicans down here, I said, "No, we got higher rates down in Victoria because everything is better in Victoria." I don't know why. So we said, well, the question is actually a very, very simple one. Our null hypothesis is nothing changes. And most people you would have actually asked about that. Everybody has a very, very distinct opinion about that. Now, as it turns out to be the case, rather very, very wonderful. Up in Queensland, we get that. Look, magnificent bird, white-bellied seagull, whistling kite, Brahminy kite. And then you go down, to Victoria, what do you get? An invasive fox, a gull, and a crow. It's actually a raven, but never mind. I mean, if anything, you ever needed a graphical display of the difference between Queensland and Victoria, but so, that being the case, you might say, surely, let's hedge our bets where we find most of the action. Everybody would have said, surely those birds of prey would actually win. Now, it actually turns out to be the case. The composition of those, communities is very, very different. Here we have, the temperate community down in Victoria and the tropical in North Queensland. So again, fox, dog, black rat, nighttime scavengers dominate down here. We have guys are daytime scavengers, and here's all the basically raptors. And no matter what statistics we actually threw at that data, and I had to say this was actually really, really, truly amazing. My postdoc Chantal led that work really magnificently. I have to say, she went back to Holland, God knows why. Is no difference. The communities are exactly the same when it comes to how much carbon, in that case, represented by carcasses they process. Now, if ever you wanted a test of functional redundancy over large spatial scales, this is it. So I'm actually quite pleased about that. It's a very, very simple one, but sometimes finding no difference, but establishing that there is statistically no difference is very, very important. Right. Now, despite all the writing here, this is what we're going to get over the next 3 or 4 years. I know exactly where to actually find them. I want to actually see a lion on a sandy beach. I think this one is actually near water, but never mind. On a sandy beach, chasing down, not us, but hopefully some carcasses. So we need to actually get more subtle data, more nuanced data on the exact nature of the spatial footprint when actually the dune shape changes. We also need to actually have some sort of idea what are the habitat attributes which actually make those edges so edgy when it comes to concentrated, forming a hotspot of function. We want to actually go and start measuring scavenging and scavenger communities in a whole landscape. Think rocky shores, think mangroves, think beaches. And we actually got the right mix of habitats right where we live. And literally this is really what we want to do. Look at the mega carnivores. What function do they actually play on ocean shores? It sounds like a ridiculous question. We have some sort of indication when it comes to, let's say, the jaguars coming down and actually eating the nesting sea turtles. But other than that, we don't really know. But I think that seems like the fun stuff to do. We also just have started to form a global network of sandy beach ecologists being interested in that. And what we actually want to do is actually create a standard set of methods which actually will allow us then to take experiments to different parts of the world in a distributed fashion and do the same stuff under completely different settings. This is how you actually build real, true global knowledge. So this is more or less, if you want, my plan when it comes to this particular area, not the deep sea and not the estuarine stuff for the next few years, and let's see how all of that goes. And of course, that's the A team. It really looks like the same shirt, but I assure you it's not. This is actually an Argentinian rugby one. And none of them would have been possible without lots of people actually working on lots of dead fish from many institutions all across, Australia and the world. So cheers to everybody. And I leave you, with the rather charming idea that dead bodies rule the world, at least when it comes to carbon processing on beaches. Right, thank you very much, and tally ho.